This is Hastings Math video, so you can find more at hastingsmath.com. This is question 1 of the October 2020 exam. The question has trigonometry and identities in it. So if you'd just like to look at the answer, I have on the right here, the question 1 already worked out. So just some notes in purple, and then the black is the full solution. So this is question 1. Okay. But if you'd like some more information, then we're going to go through it now in full. So question 1 says, between the restriction of 0, including 0 and 360, I have this equation. To cos 2x equal to 7 cos x, and then it wants you to solve for x. Okay, so solving x equals what? That's if it's asked to solve. Answer for the answer in 1 decimal place. 1 decimal place. Okay. So first thing I do is just write down my question. So we have 2 cosine 2x equal to 7 cosine x. Okay. Now, in P3, if all these things, we have to rearrange things. So the goal is to get sort of 1 x. So we want cosine x. And this thing is already both in cosine x, but this one has a double angle. So first thing I want to do is make this double angle look like a single angle. So this double angle is the problem. Okay. So we know that cos 2x can be 3 things. Cos 2a can be either any of these 3 things. So cos 2a, here are the 3 things. So cos squared a minus sine squared a, or it could be, and this is just from manipulating, just to look at this proof if you want to. All we did is we're manipulating the compound angle formula in order to get these double angles. Okay, so it's just algebraic manipulation. The second one is 2 cosine 2x minus 1, and the third one is 1 minus 2 sine squared x. So when I do these questions, I always just think to myself, where am I aiming? Well, we definitely don't want the first one because it has 2 separate, it's got cos and sine. We want it either in cos or sine because we have to solve for x. The second one is looking promising right now. I see a cos squared theta, which is useful. And then the third one would put it into cos and sine again. So if we exchanged this whole thing for this whole thing, we'd end up having cos and sine, which we don't want. We just want one trig graph to work with. Okay, so I'm going to pick the second one. So this is that, oopsie. Let's go with this one. So cos 2a, that whole thing is exactly the same thing. So cos 2a is equal to 2 cos squared x. So sorry, this should all be a's. So just to cos squared a minus 1. So we can just replace it. So this is 2 cos squared x. In this, in my working, it's an x. Doesn't matter what the variable is. And we've picked one of our cos double angle identities. Okay. So here we are with this, and we can just quickly times it in. So it becomes 4 cos squared x minus 2. I just times in the 2 is equal to 7 cos x. And bring everything to the left-hand side, and I get myself a nice trinomial. 7x on the left is negative minus 2, all equal to 0. So now we have a trinomial, and we know it's a trinomial because the cos power, this is same thing as cos x squared, so just same thing, is double the power of the cos in the middle, and it's the same graph. So both are cos, both exactly the same thing. This one is double that one. Okay, so that's how you know it's a trinomial. So I like to set it up like this. I don't use substitution methods or anything like that. I do it directly in. So I know that cos times cos will be, cos times cos will equal cos x squared. So we know that. So we can immediately do that. The 4, well, it's going to be either a 4 and a 1, or it's going to be a 2 and a 2. Okay, those are your options. The -2 can only be 2 and 1, or it can be 1 and 2. And somehow we have to make -7 out of that. Okay, so our goal, if we times it together, we get the third term, and if we plus it together, we get the middle term. And because this one's negative, 1 is going to be positive and 1 is going to be negative, either this way around or this way around. So we know we're going to be picking. So let's start with, if we had, for example, 4 and 1, so I'll just put them in green. If we had 4 and 1, then we want to make -7. So what if we took 2 and 1? If we took 2 and 1, 2 times 1 makes -2. So it'll have to be -6, -1. So I think that one works. Make sure the negative goes the bigger one. So there and there. Okay. So if I were to write that out again, a little bit neater. So 4 cosine x plus 1 cos x minus 2 equals to 0. And just, I do a little rainbow to check. So -2 times 4 is -8. Sorry, not 6. I said 6 earlier. And this is -1 cos x's. Okay, plus 1. So -8 plus 1 equals -7. And that's what we want. Okay. Right. So we've got the correct brackets. So now we know that because it's something times by something equal to 0, one of these is going to be 0. Okay, so then we can split it up. We can say either 4 cos x plus 1 is equal to 0, or cos x minus 2 is equal to 0. Those are our two options. Quick rearranging, cos x is -1/4 and cos x is to 2. Just take a look at cos x2. I can already see this is impossible because cosine x looks like this, and the highest is 1. So 2 obviously goes up there somewhere. It doesn't exist. Okay, so this one's invalid. It just doesn't exist on the cosine graph. Because the cosine graph, the y's only go from 1 to -1. The lowest y, some sort of x, the lowest y is -1, and the highest y is 1. Okay. So we know this one's invalid. And you write that in your proof. We're only working with this one. Now, how I like to do these is so many methods. This one I like to do using what I call the sticker diagram. And the reason I call this the sticker diagram, and it's this thing, is because if I call it the COS diagram, I always write it the wrong way. So it is a COS diagram. That's what most teachers call it. But I call it a sticker because if you're going this direction, then it's a sticker. All right. So the COS diagram tells us which quadrants we're going to use. Now we have to pick. First thing we need is a reference angle. Now I always take, for this method, I always take the positive reference angle. Okay. Positive reference angle. And this will be some sort of reference onto my cosine graph, which will be repeated periodically. Okay. So this will be repeated every so often. And this so often is, well, a cosine graph is every 360. Okay. But the reason we use I use a COS diagram, there's so many different ways to do it, is because it kind of does, it makes sure we don't miss anything. So how do we get our reference angle? Well, we need an x. And so to get x on its own, you take cos the -1. It takes cos the other side of -1/4. But what I do is I put this negative in a bracket. So we're actually getting, in your calculator, cos the -1/4. And this is a positive reference angle. Okay. If you have a positive reference angle, this method works. But you get your positive reference angle. I already worked it out. And I got 75.5 5, 2, 2, 4, 8, 7, 8, 1. Okay, so that's lots of decimals to add there, but that's what I got with cos to the -1/4. But remember that you're looking at where cos is negative. So cos is negative in these two quadrants. Okay, so we're not looking at where cos is positive. We take the positive reference angle to just to use it as a way of seeing where we're going. But we want to know where cos is negative, and it's negative in these two. So it's basically where it's not positive. So all are positive on there, and cos is positive over there. So it's the two that it's not positive on. We're working in degrees for this question. So this quadrant is 180 minus theta, and this quadrant is 180 plus theta. Okay. So we have two options to explore with our reference angle. So either x is going to be, either x is going to be equal to the second quadrant, which is 180 minus theta, or x is going to be equal to the third quadrant, which is 180 plus theta. Okay. Now this is P3. I'm assuming that you kind of know where that came from, the 180 minus and the 180 plus. But if you're still confused, then basically it just means that if this is the 180 mark on the, and this is 360, then we're working with sort of this part and this part. As you can see, it's under the line, so it's negative there. Okay. So that's the part of the baby cos graph, the like original cos graph that we're working with before it's been transformed. Luckily for us, this cos graph is just the normal baby one. So there's no transformations that need to be made. Okay, so we've got these two options. So our theta was this is our reference angle, okay, which we worked out over here. So you just say 180 minus 70, 7. Oops, sorry, what did I say? Is it 75 or is it 7.5? I think it's 75. This one's wrong. I think it would be 75.5, just to do all the decimal places. And then so we have, make sure you write all the decimal places. So you have the reference angle written twice into these. These are your two options. And remember, it came from these two quadrants. And then you just calculator work to finish that off. And I got rounded, remember, to one decimal place. So I got my final answer as this one. This first x came to, what have I done here? 104. 0.47, so 0.5. And this second one came to 255.5, rounded to one decimal place. Okay, so that's where all of that came from. And those are the correct answers. But just for the last step for this, using this method, is remember you had a restriction that our x could be, and I think this is not including 360. I'll just go back and check in the question. Yeah, it should be not including 360. So when you're doing this, just check your restriction. So for example, if we had x equal to 104, then it repeats. So obviously we're looking at a cosine graph. It keeps repeating. If we added 360 for the first repeat, it goes too far. It goes out of 360. It's like 464.5. And if we minus 360, whoopsie, then it goes too far in the other direction. So 104.5 is the only one. And the same thing for 255. So there's no extra solutions there. It's just those two solutions that come up. Okay, so that's the method. That's my favorite method for these types of questions. And it finishes question 1 of the P3 2020 October-November paper.